So right now we're going to take a look at hyperboloids of two sheets. So this is an example of a graph of hyperboloids of two sheets. And as you can see, there is a reason why they're called two sheets. There's one sheet up here, one sheet down here. So this is the equation, or a format of the equation of the hyperboloid of two sheets. So basically there are a few characteristics. So firstly, we have only one positive term. We have two negative terms. So what I mean by positive and negative is that the plus or minus sign. So there's only one positive term and there are two negative terms. So basically also we have three 2-degree terms, right? So we have x, y, and z because the hyperboloid of two sheet is graphed inside the 3D coordinate system. So there are 3 2 terms. So also we have a characteristic that this term, the positive term, is the axis that our graph is parallel to. So this graph is actually not equal to this equation. If we were to graph this equation here, we'd have something like a hyperboloid of two sheets that is facing this way, that is parallel along the x-axis. So this graph will actually correspond to having the z squared over c squared term being positive. So now let's just try to graph an example so you get the graphs of how do you graph a hyperboloid of two sheets. So let's try the equation. Let's say we have x squared over, actually I want to graph an easier one. So z squared over 9 plus, so minus y squared over 16 minus x squared over, let's say 25. And that's equal to 1. So that's obviously an equation of hyperboloid of two sheets. So we can use traces to graph that. If you don't know what traces are, you can look at the video about hyperboloid of one sheet. So there are 3 traces, basically really convenient to graph different point of views of a 3D graph. So we have y, the xy trace. So let's just graph that first. For an xy trace, you set z equals to 0, right? So you have negative y squared over 16 minus x squared over 25 equals 1. However, we're not exactly sure what equation that is. So yeah, you can't exactly have a hyperbola of having the right side equal to negative 1, right? So if only one of these terms or the right side is negative 1. So if the right side was negative 1, we could just multiply the equation by negative 1 and get an ellipse, right? Well, this is actually so we don't exactly have any equation or graph here for the xy plane, and that actually makes sense because where's the xy plane? So this is the xy plane, right? And if it's like this 2D plane here where z is equal to 0. However, when z is equal to 0, there are actually, so in this plane here, there are actually no points here. Like, this graph is either under the xy plane or above the xy plane. There's nothing on the xy plane, so we obviously can't graph that. So, but we still want to point of view from top to bottom on somewhere parallel to the xy plane, right? So, we can just let z equals a value so that we have the right side to be negative 1. So if z were to be equal to, let's say, so if z squared is 18, then then we have this value. So z is gonna be, so we let z be equal to root 18, or you can say 3 root 2. So therefore you have z squared over 9 squared, z squared over 9, which is 2, minus this equation. So basically you get negative y squared over 16 minus x squared over 25 is negative 1. So you can multiply the whole equation by negative 1. So on both sides, you get y squared over 16 plus x squared over 25 is equal to 1. So that's just an ellipse. So you can just graph that really easily and really quickly. So that's my approximation. So something like that. And then if we just connect those points, we have that ellipse there approximately. So now we can graph the XZ trace. So this is the Z coordinates and this is the X coordinates. So we just let Y equals to 0. We have Z squared over 9 minus X squared over 25 is equal to 1. So therefore we have a hyperbola here, and it's approximately something like this. So that's our approximate hyperbola. Or actually, in fact, because we have, so yeah, we have Z squared over 9 minus X squared over 25, that makes sense. So now let's just graph we can graph the YZ trace. So we let X equals to 0, and we have Z squared over 9 minus Y squared over 19 is equal to 1. So our hyperbola is something like that. No, oops, I made a mistake. It's something like that. And also this hyperbola is also like this, because we have the Z term to be positive, so my bad. And if we combine the 3 point of views, then we basically get this graph here. So let me just draw the 3D coordinate plane. So we basically just get this graph here. So the top view is approximately like an ellipse like that. So I'll just use a different color, like we can use red, like that. And then that's also our bottom view. And then we also have so we have two hyperbola views. So it's just something like this. So wait, let me just make that graph smaller. Something like that is our graph. So just imagine that this axis is an axis of symmetry. So that's an example of how we graph hyperboloids of two sheets. Just pay attention to the direction the hyperbolas are facing. So thank you for watching.